Here we go. All right. The home stretch. The first of three of our CephFS discussions. I think this is the first one is file creation, object level backtraces. Greg, you want to take it from here?
Sure. So there's a couple of wrapped together issues here that I want to talk about. This session started in a ticket from Alexander a while ago. I think it's number 8230. Yeah. In which he was complaining that the backtraces on clients were overloading his OSD cluster. The backtraces on files were overloading his OSD cluster because the cluster he had enough bandwidth that it was able to deal with, for instance, a certain number of, I think it was for rsync workloads. So it could deal with the rsync workload in terms of actually flushing out the files from the clients, but then the MDS was trying to update backtraces once that had happened, and it was just destroying it. So out of that, he had several ideas. One of which was the idea that it would be nice if you could have backtraces go on the metadata pool instead of on the data pool. And I'm not a huge fan of that idea, but it is one option. And my thought was, well, maybe we can just have the client actually write out the backtrace when it writes the file, because they're always doing that. Now, as Sage points out, when the clients don't actually necessarily have all the data they need to do that coherently. In fact, they usually don't. But it's easy enough to have the MDS return a buffer list with the appropriate contents when you do a file create. The reason I plumbed this together with file creation is that we would also like it if you didn't actually have to talk to the MDS to do a file creation, or at least not to talk to them synchronously. So we should talk about those issues and sort of what a good compromise or approach, or whether we care about them.
Yeah, they're mutually exclusive, right? So if the MDS has to provide the backtrace buffer list or whatever, then your create has to be synchronous so it can provide you with that information. The challenge with that is it also introduces a delay, so that if, say you create the file, say it's rsync, for example, yeah. You're creating the file as a .temp or whatever, MDS will provide the client with the wrong backtrace, or the right one at the time, that the client will then write, but then the MDS is going to have to update it anyway because it's going to get renamed a couple minutes later.
Yeah.
Or seconds later. So, yeah, I think my concern is that if it's going to be pretty complex to hand all that backtrace info to the client, and I'm not sure that it'll be worth it, basically. And I'm wondering if there are things we can do to mitigate sort of some of the bad behaviors that the MDS can do that can just generally improve the situation. I guess it's never going to fully address Alexander's problem, but it might be. Like, John, can you remind me when the backtraces are currently written out? Is it immediately when the file is created, or is it only when the log segment gets flushed?
Yeah, it's only when the log segment was trimmed.
Okay, so it's very delayed, I guess. I mean, is part of the problem just that it's going to be super bursty, and that's why, when we get to the trim part, we have like a flood of 10,000 ops that get spewed out of the OSDs, I wonder.
I think that's certainly part of it. And so just by trying to more proactively flush backtraces, either in client's drop capabilities or via some other heuristic saying we don't think they're likely to change the file name, we could do a better job with it.
I mean, clearly delaying the backtrace writes as long as possible is a good thing, because then you capture all the renames, and you're only flushing them out basically when the file is cold.
Yeah.
But doing it all at once is not ideal. That's not specific to backtraces, though. We have this general problem that when we go to turn a log segment, we're like, oh my god, we have 1 million directories to write and backtraces to flush. And
well, except usually I think we don't.
everything else.
Because usually there's not that much in a log segment, whereas this time there is.
I mean, well, whatever it is, it's going to be a burst, right?
Yeah.
You're going to have a big spike of stuff, and then you're going to wait a while, and there's another big spike of stuff.
Yeah.
And it'll depend on what the workload was. Like if you've been untarring stuff for the last 2 days, then it's going to be a huge pile of stuff. If you're modifying the same 3 files, then it's going to be nothing.
Yeah. I guess it's mostly just that this is actually, the backtrace thing is actually a scenario where we're basically doubling the number of IOPS you need your cluster to handle.
Yeah.
Which is not ideal.
Well, I mean, not just for small files, it's doubling it. Like for a small file untar workload, it's doubling it, but it's adding a per file cost. Yeah.
Yeah. But I mean, most files are smaller than one object, so.
So hold on. So actually, I said earlier that the delay is good because objects, because we capture all previous updates.
Yeah.
File is cold, but on the other hand, that it's cold, which means that it's no longer in the OST's cache, which means it's actually an expensive IO. Whereas if we do that backtrace right after the client releases the wanted caps, for example, maybe, or pretty quickly, then it's going to be, it'll be in the OST's write back cache or whatever.
So then it's just a journal hit, yeah, or it's more likely to just be a journal hit. Maybe. So go ahead.
Actually, I prefer another opinion. Maybe we can implement a general machine to store the key value in the cluster. The MDs already have a data structure called dir flag that do this, but if we extend the machine to the OSD, I think we can solve the general problem. For example, the RGW index issue.
So instead of attaching the backtraces to objects, we would just have a general key value database.
Yeah, general key value database for the OS cache. It's automatically split or merge the O map. Yeah. Maybe we can write an object class, OSD class for it.
I mean, the general problem we have with this is that we need to create an ordered lookup table, so I can look up things by inode that reverses back, but we don't know how we need to at some point scale the data set size, so we need to reshard.
Yeah,
like that's the general issue that we've been able to avoid so far by not doing it.
And this also loses us. And my concern with this issue actually is that it loses us one of the benefits we have of putting the backtraces with the data, which is that as long as we have the data, we have a way of putting it back in the tree. So putting the backtraces in the metadata pool or in a key value store, or whatever, lets us solve the lookup. Lets us solve the inode to file lookup problem, but not the reconstruction problem. For when we have a FS check and the user has just lost some arbitrary portion of their data. But the key value starts one. So here's a completely different possibility though, which I actually didn't put in the blueprint. Could we maybe just have the backtrace updates go through clients as part of the capabilities mechanism, or just when the MDS sends out an M client caps or whatever, then it says, then it includes, by the way, here's a new thing that I want you to flush out, and the client can do that or not as it pleases, and just tell the MDS that once it's done.
I mean, that's what having the clients write the backtraces would do, right?
Well, yeah, but I mean, but this would be more general. It could be that it could be a thing that doesn't necessarily need to be timed with creating the file, but just at some point while the client is working with it. Because then we deal with the fact that we would like to make file creates async, and this would allow that.
So that if it were async, it just wouldn't do that, you mean?
Well, no, I mean, it would create the file asynchronously, but then at some point it has to tell the MDS, by the way, this file exists in this directory now, and the MDS presumably has to do some sort of cap issue on it, or I mean, they do cap heartbeats basically, so it can just be like, here's this extra buffer list, which hopefully you understand, and if you do understand it and you happen to write it, then you can tell me, and I won't do it, otherwise I will.
Yeah. I suspect that if it were an async create, I guess it depends on if the client still has it open, if it still wants the caps.
Yeah, so let's talk about that, because I want to talk about that now too, is how we would go about doing asynchronous creates.
Yeah. Okay, so async creates. So the basic idea is if the client has a exclusive capability on a directory, it can obviously do the negative lookup, which it already does prior to the create to know that it's allowed to create it. But then when it does the create, instead of synchronously sending an operation to the MDS to have it assign an inode number, it would just have a list of unallocated inodes that were handed to it by the MDS, like a queue of
pre-allocated inodes
it can consume. Pre-allocated inode numbers, right? And it could just create the inode right there and do it. And then it could actually just send the create op right then, but just not wait for it. Like it just could be a non-blocking create. It doesn't even have to like batch it or anything like that. It could just fire it off. And there could be like a limit on the number of creates in flight or something to like make sure that we're throttling or something pretty simple.
Well, that's easy enough to get just by limiting how many pre-allocated ones you give it.
Yeah. So I think the challenges are, one, you have to make sure that client failures get cleaned up, which I think is pretty simple. So any inodes that you've handed to the client get cleaned up by the normal session teardown code. I actually don't think it's going to be that different than what we already have now. We need to make sure that we give the new inodes the proper attributes. So they have to get the right M time, and I guess the C time is specified by the client, but like the file mode and that based on the UMask, like all the sort of goofy Unix stuff that the MDS is currently doing, hopefully correctly. The client has to know those same sets of rules, which I think is also pretty simple. Trying to think, is there anything else that the metadata server decides when creating a file that isn't deterministic?
Well, for cleanup, we'll need to be able to reconstruct those somehow, or just make up safe ones.
What do you mean?
Like we don't store the metadata in the Rados objects. So if a client disappears before we get to create, then we go out and discover the files there. We have to like pick what the M time and A time and we just delete.
We would just delete it.
Okay.
That's what currently happens when you get the reply, but it didn't commit to the journal.
All right.
Right. It just gets mopped up after the fact. So it's no different, except instead of the MDS,
that's so easy then.
that assignment the client. Yeah. I think so. The problem here is that I remember maybe 3-4 years ago, we're doing this, so I wanted to make all of the file creation like completely asynchronous, and so that you could like untar an entire directory without blocking for the MDS. And I decided that it was too complicated at the time.
Yeah.
But I don't remember why, because now it seems really simple. I think part of the thing was that I was imagining being able to do directories too. I think we can simplify this if we limit it to just files within a directory where we already have exclusive caps.
Yeah. Yeah.
Yeah.
Okay.
I mean, if the metadata server fails and we restart the MDS, we're just going to replay the same requests the same way we normally do when an MDS fails.
Yeah.
The difference is that those creates will specify the inode number to use, which incidentally is exactly what the safe requests already do, because we get back the unsafe reply, we know the inode, and we resend it. And I think we include the inode in. I think it's going to be almost the same from the MDS's perspective, except that it needs to be. We need to add the session messages to actually hand these inodes off to the client.
Yeah. Yeah. And that'll help a lot with things like rsync workloads on their own.
Yeah.
But we still have the problem that creating backtrace create a lot of overhead on the cluster.
Right.
Yep. Right. So it doesn't solve that problem at all. It just makes untar fast.
So
but it does sort of mean that it sort of makes it harder for the client to be responsible for writing backtraces for new files because it doesn't have that information if it's doing it.
But I mean, generally speaking, it's not actually going to flush the data until after the MDS has responded, right?
Probably.
And if it does flush the data, it's probably doing a lot of flushes and things. So I'm actually still trying to put it through the mclient caps messages.
You're right. No, I think you're right.
And the advantage of that is that then it can be a voluntary thing where the MDS just says, okay, I don't have to write this.
Yeah. If you can set this attribute, let me know if you did, and I'll undirty the backtrace in the log segment or whatever.
Yeah, exactly.
Yeah, that's true. That's true.
I think the problem is that we store one backtrace for each file is too inefficient.
It's too inefficient. I mean, the setting of them, or just the storing of them, or the using them to do anything?
Storing them.
Check, or
storing them.
Storing them is inefficient.
Yeah.
So how would you want to do a lookup
case,
that didn't store one backtrace per file?
Because, for example, we can store it in our central database, or store the backtrace in OMAP, and split the OMAP when it become too large.
Yeah, but I assume you would still be keying it by inode number and then storing a backtrace next to it.
Yeah, but we still can list the key value in the central database.
Yeah.
Sorry,
yeah, I think that the problem.
I don't understand how that's smaller.
Well, I mean, it's more compact. You're storing lots of small things packed together.
Oh, I see. Yeah.
Okay. Yeah, but I mean, on the other hand, also it's certainly all together, right? And if you're doing an operation where you're querying a bunch of them, then it might be better because that data structure will be warm or something. But on the other hand, if you're attaching them to the files, these files in CephFS or whatever already have an inode associated with them, and you're sort of lumping them together with the existing metadata for that object. So I don't think that it's that part is the storage part is actually the expensive part.
Yeah.
It's more about how expensive it is to like query a whole bunch of them, do a bunch of lookups.
Yeah. It's just make the benchmark looks bad. I mean, the benchmark that creating a lot of file.
The benchmark of untarring a bunch of files.
Yeah.
Well, yeah.
I
So that's
mean,
why I'm trying to figure out how we can have the client do the
Lots of small
update,
files.
because then it's just one update to the OSDs.
Yeah. Yeah. So I mean, just to sort of paint the picture of the potentially ideal scenario here, the client goes and creates a file. It the file is created sort of, the inode is instantiated on the client. It fires off an asynchronous create to the MDS. It writes a bunch of stuff into its page cache, and it sits there for many seconds probably, and then eventually it does write pages, writes those pages out to the object store, and along with that write, it sets the backtrace at the same time. So there's actually a single OSD op that goes from the client to the OSD that writes the first object of the file and sets the attribute. And then so there's actually, in that scenario, there's no incremental cost except for the extra bytes in the create reply where the MDS says, by the way, here's the backtrace you should use, and the extra bytes in the OSD write where it says, here's the contents of the xadder.
Yeah. And that overhead is certainly lower than the overhead of the message from the MDS to the OSD anyway. So.
It'll be dwarfed by that, I think. So the thing that I worry about is, for example, the rsync workload where you create, the MDS gives it a backtrace that ends up being wrong. It gets renamed.
Yeah.
Although actually no, because the rename reply will have the emetablob, not emetablob. No, yeah. The thing in the reply, basically, that's the updated metadata for the inode, and it could attach the newer backtrace there.
Yeah.
And most likely it hasn't been written out yet. And if it has, worst case, the client had already flushed it. It doesn't write the new one, and the MDS has to write it.
Yeah.
But that's probably unlikely.
Yeah. So actually, when does rsync actually do the rename? Is it after? Because I think it might flush.
Right after it writes the whole file.
Oh, okay. It just uses it for ordering.
It doesn't call fsync.
Okay.
It writes all the bytes, sets all the attributes, and then renames.
Okay. And it's just so it knows it gets ordering that way. Yeah.
Yeah. So. And ideally your the file system is doing something vaguely smart, so it doesn't clobber the old version and lose the new version. Which I think most file systems do. They have write back ordered or whatever.
Yeah.
Data equals ordered. Yeah.
Okay.
Does that make sense, Chang?
Yes, sounds good.
So I think So the question for me is, what order do we want to do either or both of these, right?
I have no idea.
after scrub.
Yeah, I think we probably want to just put them in as tickets in the tracker, and then we can prioritize them going forward now that we know sort of like how we would like them to work. Actually, it doesn't need to go in the caps because renames are also a special request. Okay. So it should just be a buffer list on the create reply and the rename and the whatever the rename request is called.
We can add a version to the backtrace. Just like how they.
Yeah.
I mean, I think it has a version already, right? Like the last element is the version of the actual inode that the backtrace is for, and I think that.
Yeah.
Am I remembering correctly? Yeah.
Yeah. Well, we could also we might also want to add use that for ensuring that if the MDS and the client both send one off, that they apply in the right order.
Exactly. Exactly. Yeah, I think we'd want to use a Rados class that is like set backtrace version X, and it will only set it if it's the newest or non-existent.
Yeah.
Yeah. class op4. Damn. Okay. Okay.
Okay.
Mm-hmm.
Let's see. Does that? So I guess the other thing, and my opinion here is no, but we can talk about, do we want to have options for backtraces in other locations? I mean, I think that's, more complicated and less advantageous, but the scenario I've been given is that maybe your metadata is on faster storage, and so you'd like to have these sorts of things in that, but
yeah, but I think the idea here is that you're trying to mitigate that cost by putting the backtraces with the right path as closest. So I think that the place where that's going to fall down is if you have a workload that's like tons of pre-existing data and you're just renaming stuff all over the place. Yeah. Like it's a rename only workload. And in that case, yes, they're going to be hammering the data objects.
Yeah.
But whatever. So that I think so generally I would agree. I think the only thing the main thing that makes you pause is that we have this thing where we have to put the Sentinel backtrace in the data pool. Is that right? I remember this being weird. I'm trying to remember.
We have to put Sentinel backtraces in the original data pool if it gets moved before any data has actually been written, so that we can do lookups on NFS. But all that actually needs to be, I mean, right now I think it's a full backtrace, but all it actually needs to be is the right pool to look in. Does that make sense, or did you need more context?
Remind me why this is necessary.
So, we're using the backtraces so that we can do a lookup from the inode number to the file location.
Okay.
And this is in particular for NFS. And so it's conceivable that someone does a create on NFS and it's in the default pool, but then it gets moved before they've actually written any data to it. Then the pool, it gets moved to a different pool before they've written any data from it, but there's already an NFS file handle for it. So in that case, we need the lookup from that NFS file handle to work.
And in the NFS file handle, we put the original data pool that it started in, and so we know that that's where the Sentinel goes, so that you can skip this in the general case.
Yeah.
This is only if you did a set layout after file create.
Yeah.
I see.
Yeah. And I think right now it's getting a full backtrace rather than just a local one, but I don't think this is actually worth worrying about right now. Do we actually do what?
With the current, do we actually encode the original data pool in the NFS file handle and include that in the set lookup? But I mean, do we actually make it so that if the inode was created in a different data pool, we can skip this Sentinel?
No.
Oh, do we always put it in the default pool first?
Yeah.
Okay.
Yeah.
Yeah. That's
at some point. At some point that would be nice to fix, but
yeah.
The NFS re-export corner case of multiple data pools is also not a priority.
Yeah. Although it might become one.
I guess there would
just be. I mean, multiple data pools is a thing that I think is going to be popular, but we'll see.
Yeah. Well, so I mean, the thing to do here is that in the inode there need to be a field that is the original data pool for this inode.
Yeah.
Yeah.
Essentially, yeah, and that would need to be included in the NFS file handle we generate. And when we do lookup by inode, we need to provide that original data pool so we know where to find the Sentinel.
Are you sure that's not implemented right now, Jean? Because I remember that we will go around through, we have a thing where we loop through and say, okay, what's the older pool, what's the older pool in case it gets moved around multiple times.
Yeah, currently we put a backtrace in the default data pool for each file.
Yeah. And then also
So
next to it, right?
So if we don't know which data pool files is in, we look up the default data pool first. Then.
Okay.
Let's see.
Okay. I think we must also encode it in the file handles, because I remember there being a thing where we put it in all of the data pools it's lived in case it got picked up at any one of them.
Problem is another machine. Hardlink also use the backtrace. So we still need to add backtrace to the default data pool.
Yeah, we probably just need it there anyway. But
this all makes me wonder if we couldn't have just put the oh no, that went out. Never mind. The data pool in the inode number. But like in the top 16 bits or 8 bits or something.
Oh, wow.
Again,
that nice.
It's because you can set the layout. It's because you can set the layout and change the data pool as long as you haven't written data yet. And so
yeah, but that means that you only worry about it in that case and not, and you don't need it.
Yeah.
You don't need to put it all in one pool for lookups. Because actually, that's the other thing is that we get the inode and we say we need to know where it is without any other metadata. So you need it in one place, and if the inode number encoded to the pool, that would help.
Yeah.
Well,
I think you accomplish the same thing by saying that anytime you have a reference to something by inode, like an NFS file handle or a remote link, you just include the pool at the same place, right? And you can accomplish the same thing.
Yeah.
And then you have a field in the actual inode T that has that original pool.
Yeah.
Does the same thing. So I guess so this is sort of looping back to Jung's original idea. Instead of having these smattering of 0-byte objects with a backtrace set on them in the data pool, you could use a central table, key value table, to store that exceptional case where you aren't storing it alongside the data. But again, you have the problem that we don't have that storage primitive right now. We don't have something that's auto sharding and efficient for small key value stuff, except objects, which it's sort of, I guess, they should be efficient if they're small. So it's sort of the same thing, right? Right there. It's lookup by a random. It's a hashed distribution. You're looking at by an identifier. You don't need to enumerate them in sequence. So that's really what Rados is doing.
Well, but Rados is built for much larger objects than that.
Right. Yeah, it's just not optimized for small stuff. So.
Right.
Yep.
All right. Anyway, I think we covered unless you guys have something you really want to talk about, I think we covered these topics, and we have two more sessions that I want to get through.
Yeah.
Although the next one might be shorter. We'll see.
All right. Time to bid the flip.
Yeah, do you